Alrighty, here we have Kramer's rule, a 3x3 system this time, which very similar to Kramer's rule with a 2x2 system, except that it has an extra variable in there, extra equation and extra variable. So once again, this looks very similar to the 2x2. It says let A, so we're looking at matrix A, be equal to the coefficient matrix. So the coefficient matrix, A, D, G, B, E, H, these are all the coefficients, and C, F, I. And this is the coefficient matrix of the system that we have. And so when we start putting numbers in there, you'll actually put numbers down here in the matrix itself. So in its solution, in order to find, okay, so we look, if determinant of A is not equal to 0, then the system has one solution. So we find the determinant of this matrix, and if it is not 0, then we know it has a solution, and we use this this rule here. Let's look here. We notice, if you just pay attention here, I'm going to erase some stuff. I'll put it back in a second. If we notice here, we're trying to solve for the x. So JK now, I'm sorry for the switching around, but I was running out of room here. JK and L, which is the numbers without variables, JK and L get put in there for x, for the x coefficients. The y and z coefficients are the same as they were in matrix A. Looking here, we're solving for y, so JK and L get plugged in for the y coefficients. And in z, they get plugged in for the z coefficients there on the last column. Okay, so this is where we're at with the determinants and using them to solve Kramer's rule for a 3x3 system. Okay, well, let's get started. Let's look at one. So if we look here, to solve this, well, matrix A is going to be these numbers, 3, 2, 1, these numbers here, and we have a negative sign there. So let's make sure we pay attention to that. And these numbers here, 5, -1, and +3. This is matrix A. Imagine the matrix or the brackets around it to make it a matrix. But we're going to calculate the determinant. So let's rewrite the first two columns so we can calculate the determinant and go ahead and solve that. Now, I'm pretty sure that we've already done this in the notes from determinants. So you go ahead and if you were to go ahead and work this out like we did in our notes for determinants, we would determine that the determinant of this, I believe, was 63. That the determinant of that is 63. So, all right, that's the determinant of A is 63. Now, let's look at, give me a blank slide here. Now we want to calculate x. So the x terms, or I'm sorry, the x coefficients will be replaced with these three numbers, -3, 9, and 15. So -3, 9, and 15. And y and z are going to go ahead and stay these. And remember, we are calculating x. We're calculating x, so there we go. Find the determinant of the top, and let's go ahead and do that. Negative 3 times positive 3, negative 9. That's positive 1. Negative 1 times negative 1 is positive 1 times 15 is 15. And 5 times 9 is 45 times 4. 45 times 4, 45 times 4 is 180. Now let's do the downs. I'm sorry, the ups. We're looking at the ups now. Negative 15 times 1 times 5, that's going to be 75. 4 times negative 1 is negative 4, times negative 3 makes a positive 12. And 3 times 9 is 27, times negative 1 is negative 27. And so now let's go ahead and figure out what this is. We're looking at 186 minus 75 and 12 make 87, minus 27 should give us 60. And 186 minus 60 is 126. So now on top of the fraction, the determinant of that matrix was 126. On bottom, we know the determinant of A is 63. So therefore, the x value is 2. The x value is 2. All right, so there we go. That's the x value. Now in order to find the y value, we do the same thing. In order to find the y value now, we are going to plug in negative 3, 9, and 15 for the y coefficients. The y coefficients right there in the middle of determinant A will get negative 3, 9, and 15. So we still have, we're still going to go 3, 2, 1 for the x's, negative 3, 9, and 15 get plugged in for the y coefficients, and then the z coefficients still stay 5, negative 1, and 3. And so, let's go here, and I guess I don't have a paste in that menu, but I do have one right there. All right, we're going to calculate for y, so let's go ahead and do that. We're going to say this y is equal to, and remember the determinant of A is 63. So let's rewrite the first two rows, or I'm sorry, the first two columns. So we have the first two columns rewritten. Let's go ahead and do those calculations. Let's do the downs. 3 times 3 is 9, times 9, that's 81. We could have done 27 times 3 is 81 also. 3 times negative 1 is positive 3, times that is positive 3 again. And 5 times 2 is 10, times 15 should be 150. And we're going to subtract the ups. 9 and 5 make 45. 15 times negative 1 gives us negative 15. And negative 15 times 3 gives us negative 45. 3 times 2 is 6, and 6 times negative 3, negative 18. So let's go ahead and do some calculations over here. We have 81 plus 3 gives us 84, plus 150 should give us 234. We're going to subtract, well, we know 45 minus 45 cancel each other out. And so we're going to subtract negative 18, which should make positive 18. So that's 234 plus 18, 234, 242, and 252. So we have 252 divided by 63, and 252 divided by 63 should be 4. Should be 4. All right, we know what x is, we know what y is. So in order to find z, I say we plug it back in and calculate it. I'm going to use this one right here. We calculated x to be 2. We calculated y to be 4. Subtract z, and that's equal to 9. 2 times 2 is 4, plus 4, which is 8. 8 minus z is 9. Subtract 8 from both sides. We have negative z is equal to 1, and so therefore z is equal to negative 1. Put your answer into a set of parentheses. X is 2, y is 4, z is negative 1. There's your solution. Okie dokie. The next example here. Next example we're looking at is right here. You probably want to check your notes on a determinant, on determinants there, because I believe once you set up the determinant, or once you set up matrix A and find the determinant of it, you may find that it's already in your notes there. So why don't you take a moment to try to work this out on your own. Pause the video. If you feel confident, do it on your own, and then check the solution. If you feel like you need some help, why don't you try to follow along with me, but try to do as much as you can on your own. Okay, if you notice there that we have this system of equations here, and back in your determinant, we calculated the determinant of A to be negative 1 there. Here would be A, matrix A right there. So if we look here, how do we solve this? Well, we want to go ahead and solve for, the x. Whoa. Let me get a different color here. We're going to put numbers without variables in for the x's, since we're going to be solving for the x's. And then we go ahead and put the y's and the z's, the coefficients in. So we have 2, 3, negative 1, and we have 1, 2, negative 1. We're going to find the determinant of that, so I'm not really going to put the vertical bars up there. And the determinant of A was negative 1 there, so let's go ahead and put that on the bottom. 1, 5, negative 3 is there, and 2, 3, negative 1 is there. All right, let's go ahead and calculate this. Just calculate the downs. I believe that's negative 3. And calculate the downs. That's 4 and 3 make 12. And there's negative sign, so that's negative 12. And continue on with the downs, that's negative 5. Do the ups. Negative 9. The ups here gives us negative 2. And here gives 10, negative 10. Okie dokie. Let's negative 3 minus 12 minus 5. Negative 3 minus 12 is negative 15, minus 5 is negative 20. And then we're going to subtract whatever's in the second parentheses, which happens to be negative 21. Subtracting a negative means that we get to add those two. Negative 20 plus 21 should give you a positive 1 over top of negative 1, which the answer then for x is positive 1. The answer for x is positive 1 there. Positive 1? I can't believe you're agreeing with me. See that negative sign? Positive divided by negative makes a negative. X is negative 1, silly Billy. Okie dokie. So now that's x. That would be x. And we need to find y. There we go. And back up. Now let's calculate y. Calculating y. So we know 1, 5, and negative 3 go in for the y coefficients. So x coefficients are still there. 1, 5, negative 3. And for the y coefficients, z coefficients, 1, 2, negative 1. 1, 2, negative 1. We're trying to find the determinant, so rewrite the first two columns again. And let's go ahead and calculate the determinant. Downs give us negative 5, 2, and should be positive 3. Add those up, I think we get something like a big 0. All right, ups. Oh, 5. And negative 3 times 2 is negative 6. And negative times negative is a positive. Times a positive should be a positive 1. So we're going to subtract negative 5 minus 6, negative 1 plus 1 is 0 again. 0 minus 0 is 0, divided by negative 1, which is 0. That's simple enough. Simple enough. All right, now let's find z. Let's find z by plugging it back in and plugging it back into one of the equations. Let's go top equation here. Negative 1 plus 2 times 0, since y is 0, and plus z is equal to 1. Well, we know 2 times 0 is 0, so we really don't need it. We want to add 1 to both sides, so that leaves us z is equal to 2. And we go ahead and put 2 in there for z, and voila! Voila! C'est fini. Fini. I don't even know if those two are part of the same language, but I know that that's the correct answer. So, I understand Cramer's rule with 3x3 system takes a little longer, but here it is. There you know it. I'll see you soon for any questions.